Good morning, Algebra 2. Today we're going to continue on from what we talked about yesterday with, say, horizontal asymptotes being the main focus. So we are going to first take a look at the situations of what happens when n is equal to m. Now, I went over this with you briefly yesterday. When they're equal to each other, we simply have to take the ratio of the two. What we did as of yesterday looked like questions like this, where we simply have the numbers provided for us, and we could just figure out where the vertical and horizontal asymptotes would be. And from that point onwards, it's just a matter of sketching and plotting the points, and off you go. So here, in these types of situations, what do we have to do? Well, you will still do the same thing where you're still going to be looking for all of those components, but the very first thing you should always take a look at is the vertical asymptote. And so the vertical asymptote will happen at x equals -4. So I'm just going to plot that right here. It's because we both know that it's whatever makes the denominator to equal 0. And so we are going to first establish our framework. Now the question is the horizontal asymptote, and this is going to be the main focus of today. And you'll be encountering a lot of these questions that look similar to what you see in this first example. Now, the situation number 2, as I would like to call it, because we're never going to see situation number 3, is that the ratio of the degree of top and bottom is the same. What do I mean by degree? The degree is the exponent of the leading coefficient. So for instance, something like this. The degree is 1 for top because it's x to the first power. That's the leading term. So degree is 1. That's the exponent. What's the degree of the denominator? The leading term is x, and the leading term's exponent, it's also 1. So since they're the same thing, this will be a classic example of when you will actually take the ratio of the coefficients between these two. Now, also what I told you yesterday was that if that is a little bit too hard to understand, what you can always do is plug in a very big number for x and try to see what happens when you do that. When you plug in a very big number for x, this -3 and the +4 is so small to the infinity, the big number that we plug in, that it's almost negligible. And you only take a look at the x's and go, okay, so I just have to cancel these out and say that that's going to be 1. So your horizontal asymptote in this case will be y is equal to 1. Okay, it's no longer this +3 at the end, what that number is going to be. That's no longer your horizontal asymptote. You actually have to figure it out by looking at the ratio of top and bottom of the leading terms only. So vertical asymptote, we already established that. And so I am going to go to my graph and plot y is equal to 1. So that would be my horizontal asymptote like this. Any additional points? That's what I mean by testing points. Yes, we definitely do want testing points. Testing points I always like to figure out by looking at the vertical asymptote, which is at x equals -4, and pick a number that's left and right of that. So x equals -5, x equals -3 seems like a better choice for me. So -3 and -5, I'm going to plug those in. Why do we want to plug those in? Well, it turns out that when you plug these values into the denominator, you get a very nice 1 or a -1. And that's really why. So -3 minus 3 over -3 plus 4 is equal to 1, as you can see in the denominator, -6 over that. So it's -6. When I plug a -5 in there, and the denominator will say -1, and the numerator will say -8. So it's just going to be +8 like this. So -5, 8, I'm going to plot it here. -3, -6. I'm going to plot it down here. So it kind of seems to me that I'm going to have this sketch right here going down and going through this point. And I'm also going to have a sketch that looks like this. So it's an opposite boomerang like we always talked about. Holes, we're not going to talk about that as of yet. I want to establish a very strong foundation on the rational functions and how to sketch these things first before we talk about the holes. We're going to sketch them. Domain and range, we've already done that. And so domain and range is the only thing that's missing. So the domain and range is quite simple. All you really have to say is all real numbers except x equals -4, all real except y is equal to 1. Now, you'll probably notice some sort of a pattern here. These two are exactly the same as your horizontal and vertical asymptotes. What does this mean? Well, it means that the y value is present through everywhere, like vertically, it goes all the way to the negative infinity, all the way to the positive infinity, except that boundary line where it's at y is equal to 1. There is no physical point when y is equal to 1. So that is like the cutoff boundary for all the y's out there. Everything except 1. Same thing happens for the x's as well. You can see how x goes all the way to the left, all the way to the right, and all the way to the left. But then this one particular point, the value is at -4. There is no x values present. Remember, the asymptote, it means that it approaches, but it never touches or crosses it, right? So since there's no physical point present at -4, that's why x cannot equal to -4 for the domain. Okay. All right. So today I want to give you guys a lot of these types of problems for you guys to do. I will skip any questions with the holes. So I want to give you an example. So let's try something like this for independent practice for the video for today. I would like for you to pause the video and try to see if you can come up with all of these components. There is no holes, so please skip over that and sketch this for me, please. All right, so first we should all understand that the vertical asymptote will happen at x equals -3. When you set this equal to 0 and you can solve for it, add the 6 divided by -2, you know the drill. Now the horizontal asymptote, remember, you're plugging in a very, very big number for x. So if you plug in x as infinity here and here, that means that the +4 and the -6 are so small and minuscule that it's like it's disregardable, if that's ever a word. So x over -2x simply means I can just kind of cancel those out and say I take the ratio of the two. That becomes, there's technically a 1 in the front, so it's 1 over -2. So the horizontal asymptote will happen at y equals -1 over 2, like this. So I'm going to go to my graph and I'm going to plot -3 and y equals -2. I'm -1/2. So I have my framework established as such. So I have everything I need. Any additional points? Yes, definitely. I have this vertical asymptote. So x equals -4, x equals -2 will do. So I'm going to create these two testing points. I'm going to erase all these eraser marks. I'm going to plug it back in. So by plugging in -4, coincidentally, it actually ends up being a 0 for the top. So that's convenient. -2 plugged in, well, that's going to give you what is that going to give me? That's -2 in the bottom, and that's +2 at the top, so that should be at -1. Okay, so good points. -4, 0 and -2, -1. So you can see that if I were to sketch it, this one point is on the bottom right corner of those 4 window sections, and this point is at the top left corner. So I can just kind of sketch it like this, opposite boomerang. I sketched it, domain and range, always it follows the format. All reals except x equals -3, all reals except y equals -1/2. Okay, so I hope this video helps. So your main objective is for you to master the concepts of when the degrees are the same and how to sketch these. That should be it for today. Hope you guys having no problem with the homework with today's lesson. I'll see you guys tomorrow.